Okay, so I welcome you again in this lesson, and we are continuously looking at polynomials, integration of polynomials, and circular, or one can call them trigonometric functions. So last time we did only 2 examples here, and I told you that you revisit the integration of even powers so that we can progress, and that is where I'm going to start from. I'm going to start looking at more examples. Find Roman 1 integral of x squared sine squared x dx, and Roman 2 integral of x cos squared x dx. Then part B, we are going to evaluate the integral from 0 to a half pi of x squared cos x dx, and Roman 2 is the integral from 0 to pi over 4 of x then tan squared x dx. So we are going to look at these, and this is very, very, very interesting. From the previous videos, we've already looked at integrals of these even powers, so it's going to be something very easy for us. Let's begin with part A. Solution. I'm beginning with part A, Roman 1. We are having the integral of x squared sine squared x dx. We say that the function that can easily be differentiated, we need it to be u, and the function which can be easily integrated, it becomes our dv dx. Therefore, we shall have to let our u to be equal to x squared, since it can easily be differentiated up to when you reach 0. So let me let it be x squared. And then I will let my dv dx to be equaling to sine squared x. So that if I differentiate this one here, I'll get my du dx, which is going to be equal to 2x, and my v is going to be equal to the integral. If this is dv dx, then to get v itself, it's the integral of sine squared x dx. Since this one may not need to take me too far, of course, you know that sine squared x itself, this one can be expressed as a double angle, and this is the same as a half into 1 minus cos 2x. When I was integrating even powers, I showed you how we get sine squared x to be equaling to this. All right. So I don't know whether we are still following the other thing. You can maybe replay. You can replay, and then you have how we got it. So now, of course, when we integrate this, it is going to be a half x, or one can say a half into x Then when you integrate cos 2x be minus, if it is a 2, then we shall move a half down, so it will be a half sine 2x. That is what we get as our v, okay? So for simplicity, maybe one can say the v dx is equals to sine squared x, which is at the same time equal to a half into 1 minus cos 2x. Let me hope that all of us can guess where this one comes from. Do we know where it comes from? Do we all know where this one comes from? Yes? Okay. That's very good. Members have been following. So now, what we do, then now we start integrating. So we shall say that our integral of x squared sine squared x is equals to, we substitute in the formula of integration by parts, which is uv minus integral of v du dx then dx. So it is going to be our u is x squared. So you just substitute, it will be x squared times v, which v is a half times that. So it is going to be a half x squared into x minus a half sine 2x, all right? Then minus integral of v du dx. My du dx is 2x, so it is 2x. Then times v is a half x minus a half sine 2x. So that is what we are having, and that is what I am integrating. Okay, then of course, with respect to x, I will say dx, all right? So it's going to be equal to a half x squared, x minus a half sine 2x, then of course minus, these two will go with this, so I will remain with minus integral. Here will be x squared. If I multiply x and x, it will be x squared dx. Then this of course would be plus, it will be plus integral of a plus half integral of x sine x dx. Let me bring more light here. This 2 cancels with this 2. X multiplies here, it becomes x squared. It also multiplies here, it becomes x, a half x sine x. Actually, I forgot a half. I can put it outside here. So a 2 cancels with a 2. X times x, x squared. But because of this minus, it will be minus x squared. Then this minus will multiply here, it becomes positive. But because we have x and sine x, will be a half x sine x dx. So that is what we are having. This is the same as a half x squared into x minus a half sine twice x. Then minus, when you integrate this, you'll get x cubed over 3, which is a third x cubed. Then, of course, here, after reaching here, I will say plus, this one I will integrate it separately because it is also bringing any more by parts here. It is x a half, integral of x sine x, so dx. This one here, we can apply another by parts. So we shall say let u equals to the easily differentiated function, which is x. Actually, it is supposed to be sine 2x. I don't know why I'm moving with x alone. Sine 2x, sine 2x. So let u equals to x, and let dv dx be equals to sine 2x. Equals to sine 2x. Now, it means that your du dx will be equaling to 1, and your v will be, when you integrate sine 2x, you get negative a half cos 2x. Why negative? When you integrate sine, you must get a negative, but because of this 2, it becomes a half cos 2x, implying that the integral of x sine 2x, sorry, dx will be equaling to uv, which u is x times a half negative. So it will be negative a half x cos x, then minus integral of v du dx. Du dx is 1, then v, that is negative a half cos 2x, then dx. So it's going to be negative a half x cos x, then plus, this is plus, because of this. So plus a half, I can put my half outside, integral of cos 2x dx. That step may not be too necessary, but because I want us to flow together, so it is negative a half x cos x. When you integrate cos, you get positive sign, but because of this 2, it will be a half, which multiply with this and it becomes a quarter. So plus a quarter sine twice x. This is a half x cos 2. It is cos 2, cos 2, cos 2. Okay. So here we shall get a quarter sine 2x, a quarter sine 2x, then plus a constant of integration. Then now we are going to substitute for all this. We're going to substitute for all this. We bring it here. Shall substitute it here. So let me call this one maybe star, so that we substitute into star. So substitute substituting for integral of x sine 2x dx into equation star. So if we substitute it into equation star, we are going to have all this the way it is here. We shall bring it in here, and it is going to become, since I'm going to rub this, so I don't know how I'll quote it, but let me see. So we are going to have our integral of x squared sine squared x dx equal to, it was a half x squared into x minus a half sine 2x, then minus a third x cubed. Then we shall bring in that integral plus, so it will be minus a quarter. I'm substituting minus a quarter x cos 2x, then plus 1/8 sine 2x plus a constant of integration, which is going to be equal to, this one would be a third x cubed Let me see. This is a third x cubed. A third x cubed. A third x cubed. This is a half x cubed minus a third x cubed. We shall have a sixth of x cubed. Then minus a quarter x squared sine twice x, then minus a quarter x cos 2x, then finally plus 1/8 sine 2x plus a constant of integration. So that is what we are having. That is what we are having. Before maybe I entertain anything from you, let me first use basic technique, and you see, using the basic technique, we are going to have sine here. We shall differentiate and then integrate. I'm entertaining it to any question later. Integrate. So the sign, we shall begin with the positive. The function which is easily differentiated is x squared. The one which is easily integrated is sine squared. So we shall begin. Remember, this sine squared is the same as, we say that sine squared x is the same as a half into 1 minus cos 2x. So this is the same as a half minus a half cos 2x. So you need to know that when we are integrating, let's consider this one, which is simplified. So when we say minus here, when you differentiate x squared, you'll get 2x. But when you integrate sine squared, we say that it would be a half x minus this will be a quarter sine twice x. Then we say plus. When you say plus, here when you differentiate it becomes 2. But when you integrate here, it will become a quarter x squared, because it will be x squared over 2, which will find a 2 and it becomes 4. So it will be a quarter x squared. Then here, of course, when you integrate a sign, you get negative, which will multiply here, it becomes positive. So it will be plus 1/8, because the 2 will come down, then cos 2x. Then minus, when you differentiate here, you'll get 0. And when you integrate here, it will become x cubed. Of course, here, it is going to become x cubed over 12. Isn't it? It is going to become, if this is a quarter x squared, after integrating, it's going to become 1 over, what does it become, members? X cubed over 12. So it is going to become 1/12 x cubed plus 1/16 sine 2x. So if one had put lines to separate these are we shall say that this one matches with this. Then this one will match with this. And then this two will match with that. So now, this one would imply, that our integral is going to be x squared sine squared x dx. But let's always, if you can use the other one better, this one here, you can easily make a foul. You can easily make a terrible, terrible mistake. So it is going to be x squared. You're going to multiply this x squared with its positive into this. You multiply this negative 2x, you'll bring it with its sign into this. Then this into this, and you simplify and see if you will get that. So that one, I'm giving it to you as let me call it an assignment to see whether the basic technique will give you the same thing. Because in the previous video, I was showing you, or in the previous lesson, the other previous lesson, I was showing you how to use basic technique with the signs. You bring the whole of it with the sign, the whole of it with the sign, the whole of it with the sign, and then you simplify. Let me attend to any question before I go to part 2. Questions? Is it very clear to us?
Yes, sir. Do you post any of these lessons like on YouTube? Because I'm kind of having a problem with my Wi-Fi connection.
I will inbox you. Yes, all the links from lesson 1. So that is it. You are going to follow from lesson 1. Otherwise, if you margin in the middle, it may be a bit tricky for someone. So members, let me go to part 2. Let me go to part 2. So part 2 is having integral of x, then cos squared x dx. If you're having this, of course, we shall let our u to be equal to what? What would be our u? X. Then our dv dx is going to be equal to cos squared x. But this cos squared x, when you evaluate it, it is going to be a half 1 plus cos 2x, which is the same as a half, plus a half cos 2x. Now, it means that our du dx is equals to 1, while our v is when we integrate the v dx. So it is going to be a half x, all right? It's going to be a half x plus a quarter sine x. Actually, sine 2x. or one can write it as a half into x plus a half sine 2x. Still you are okay. Now, it would imply that my integral of x cos squared x dx is the same as uv. So my u is this x, and my v is a half this. So allow me to say that it is equals to uv. So I will multiply x into this. So it is going to be a half x squared. If I multiply x into that, a half x squared plus a quarter x sine 2x. In other words, uv, I'm multiplying x into v. So it is a half x squared, a quarter x sine 2x, sorry. Then minus the integral of v du dx. Integral of v du dx. Du dx is 1, but v is a half x plus a quarter sine 2x, everything dx. So this is going to be equals to a half x squared plus a quarter x sine 2x minus, let's begin with minus integral of a half x dx. Then another minus even this integral of a quarter. I've just split it for easy integration, a quarter sine 2x dx. So it's going to be equal to a half x squared plus a quarter x sine 2x minus, when you integrate this, you're going to get a quarter x squared, because it's x squared over 2, which will be a quarter x squared. Then when you integrate sign, remember you get negative, so it is going to be plus, this will be over 2, so it will be plus 1 over 8 cos 2x plus a constant of integration. A half x squared minus a quarter x squared, a half x squared minus a quarter, you remain with another quarter. So it is going to be a quarter x squared plus a quarter x sine 2x, then plus 1/8 of cos twice x plus a constant of integration. As simple as this. Basic technique also brings it clear. Now, for basic technique, actually, this is very easier because it does not repeat the integration of by parts. It does not come back here. So you just integrate once. So you can try the basic technique also. Or let me give you a ground idea on basic technique. Since it is the integral of x cos squared x dx, we shall have the sign here, differentiate, and then integrate. Positive, we shall differentiate x, we shall integrate cos squared x, which we said is the same as a half plus a half cos twice x. Then we say minus, we differentiate x, we get 1 And if we integrate this, we shall get a half x plus a quarter the sine of 2x. We change sign positive. When we differentiate here, we shall get 0. And when we integrate this one, we shall get a quarter x squared minus 1/8 cos twice x. Then from here, you match. You match this one with this. You match this one with this. With your table completely crossed. So looking at this, we are going to have our integral of x cos squared x dx equal to, you match this with its positive sign. So it is going to be a half x squared. Okay, let me say x into a half x plus a quarter sine 2x, then minus, because we come with a sign, 1 times that. So it is going to be a quarter x squared minus 1/8 of cos 2x, then plus a constant. So when you expand this, you're going to get a half x squared plus a quarter x sine twice x minus a quarter x squared plus 1/8 of cos 2x plus a constant of integration, which reduces to what we said, a quarter x squared plus a quarter sine 2x, a quarter x, sorry, sine 2x, then plus 1/8 cos 2x plus a constant of integration. The same. So if understood members, upload me a yes. If understood, upload me a yes. I take you to those of evaluation. I take you to those of evaluation. And we see. So part B of that question is about evaluating. So we are evaluating. And the first evaluation is integral from 0 to a half pi of x squared cos 2x. Then here dx. So this is very easy. This is very, very easy. Now, the first example we did on this was about, we integrated this one only. So now we are plugging in the limits, but for easy review, let's see. So we shall first let our u to be equaling to x squared and our dv dx to be equaling to cos twice x, so that my du dx is equals to 2x, and then my v, when I integrate cos 2x, I will get my v, actually it is It is just cos x, sorry, just cos x. So when I integrate my v, I'll get sine x just. So this can be easy because you have it. Let's first discard the limits. We shall put the limits later. So from 0, no. Let me first do it without limits. So x squared cos x dx is going to be uv. So it is x squared sine x minus integral of v du dx. So it is 2x, okay, 2x sine x, then dx, of which it is going to be equal to x squared sine x minus, I can move out at 2, integral of x sine x dx. It brings back the by parts, so you can still let u to be x and dv dx to be equal to sine x. I've done that because u can easily be differentiated, x can easily be differentiated, and sine x can be easily integrated. So du dx is going to be 1, while v is going to be, when integrate sine, you get negative cos x. Now, it implies that the whole integral x squared cos x dx is going to be x squared sine x minus 2 into, now I work on this. It's uv, of which u is x, v is negative cos x. So it is going to be negative x cos x minus the integral of v du dx. V is negative, so it is going to be plus cos x dx. Why that? Because this is negative and we had to subtract here, and du dx is 1. So it's going to be x squared sine x minus 2 into negative x cos x. Then when we integrate this, you get plus sine x, and then a constant. Before we put in the limits, it will be plus a constant. Then it's going to be equal to x squared sine x plus 2x cos x, then minus 2 sine x plus a constant. Then when we put in the limits, it would imply that the integral from 0 to pi over 2 or half pi of x squared cos x dx is going to be equal to, shall plug in the limits, x squared sine x plus 2x cos x minus 2 sine x from 0 to pi out of 2. So we shall first plug in when x is pi over 2. Then after we plug in when x is 0. So it's going to be equal to, for x squared here, it's going to be pi squared over 4 because it is x squared. So we shall square this, it will be pi squared over 4 sine pi over 4 sine pi over 4, then plus, they are saying 2x cos x. So 2 times pi over 2, it will be just x. It will be pi, because it will be 2 times pi over 2. A 2 will cancel with a 2, you remain with pi. So we shall have pi, then cos pi over 2, then minus 2 sine x. So it will be minus 2 sine pi over 2. So this is when we substitute the upper limit, then minus. We shall subtract minus. Let's say minus. Now here we shall substitute when the limit is 0. Of course, when you put x as 0, the whole of this will go. The whole of this will go. So we shall remain with the 2 sine 0. Just 2 sine 0. It's going to be equal to pi squared over 4, because sine pi over 4, sine pi over 4, pi over 4, it's like 180 over 4, which is 45. But still, you can put your calculators in radians and then you put sine pi over 4. This one will keep pi squared over 4. Cos pi over 2, of course, this is cos 90, which is 0. The whole of this is 0. Minus sine pi over 2, 90 over 2, sine, that is a 2. It will keep as a 2. Then minus 0. So one can finalize as pi squared over 4 minus 2. Or you can put your calculator in radians and you evaluate these figures. You can put your calculator in radians and evaluate. If understood, type yes. If understood, type yes. If understood, please text yes, write a yes. Good. So let's do another question. Another question is where we have the one of tan. So it's the integral from 0 pi out of 4 x tan squared x dx. You can use basic technique. You can use a normal thing. Still, you are going to get the same answers. Then you apply the limits. In other words, from this one, we can let u to be equaling x, and we can let dv dx equaling to tan squared x. Remember, tan squared x the same as sec squared x minus 1. So it would mean that our du dx is equals to x to 1, and our v, when you integrate sec squared x, I told you that you get tan x. When you integrate sec squared, you get tan x, and when you integrate 1, you get x. So that is what we are having, implying that our integral of x tan squared x dx without limits first is going to be equal to uv. So it is going to be uv, which is x tan x minus x squared then minus integral of v du dx. V is tan x minus x, where du dx is 1. So it is going to keep tan x minus x, then dx. This is going to be equal to x tan x minus x squared, then minus the integral of tan x dx, then plus the integral of x dx. This is going to be equaling to x tan x minus x squared minus, when we integrate tan, I want to remind you that we get negative ln cos x. I'm going maybe to remind you here by proving negative ln x, then plus a half x squared or x squared over 2, then plus a constant of integration, which reduces to x tan x. Of course, here we have minus x squared plus x squared over 2. So we shall remain with minus a half x squared. So plus ln cos x because of negative negative. Then minus x squared plus x squared over 2. We shall remain with a half x squared plus a constant of integration. Maybe reminder, how we integrate tan x dx. You do believe that, or you remember that tan is the same as sine x out of cos x, then dx. So if I let my u to be equaling to cos x, it would mean that my du is going to be equaling to negative sine x dx. I've differentiated both sides. Du is going to be equaling to, in other words, it is 1 du is going to be equaling to negative sine x dx, implying that my dx here is the same as du out of negative sine x. Substitute everything here. It would imply that your integral is going to become sine x over, we had let cos x to be u, times dx, which dx is du out of negative sine x. Sine x will go with this, so we shall be remaining with the integral of negative. I can put negative outside, then I say du out of u, or 1 over u du. 1 over u, when integrated, you get ln u, but negative outside. So this is going to be negative ln, but u is cos x. So that's how we get it as negative ln cos x. So after getting this value here, we are going to put the limits from 0 to pi over 4. So our x tan squared x dx is going to be equal to, our x tan squared x is going to be equal to, of course, we have it as this, so we just plug in the limits. It's going to be x tan x plus ln cos x minus a half x squared, then limits from 0 up to pi over 4. So you will substitute, you're going to substitute beginning with the upper limit. So we shall have pi over 4 tan pi over 4 plus ln cos pi over 4 minus a half pi over 4 squared. Then minus, when you substitute a 0, it will be 0, it will be 0, it will be 0. So everywhere we shall subtract and it will be 0. So it's going to be pi over 4. This is like tan 45, which is 1. So it is going to be pi over 4 plus, you go to ln cos pi over 4, cos pi over 4, that is cos 45, which is root 2 over 2. Minus, this is pi squared. Of course, this is 16, pi squared over 16 times 2, which is pi squared over 32. So it is going to be pi squared out of 32. So this one can be stopped there. That one can be stopped there. So that is what we are having. However, actually, we can continue because you may be given like a proof when it is very continuous. So this one is very easy to continue. I can say, what if maybe it was a proof? Maybe let's continue. You can say pi over 4 plus ln. When this 2 moves up, it will be 2 power negative 1, and root 2, you know that it is 2 power a half. We subtract pi squared over 32. So this is the same as, let me come this side. It is going to be the same as pi over 4. Okay. This one being 2 power 1 power negative 1 times 2 power half, this is the same thing. So allow me say that it is plus ln. It is under the same base, so it is going to be 2. I will add the powers. Negative 1 plus a half, it will be negative a half, 2 power negative a half. Then minus pi squared over 32. So this is going to be equal to pi over 4. This half, ln behaves like a logarithm, so this half will come here. So it will be minus a half ln 2, minus a half ln 2, and then minus pi squared over 32. So after this, I can move out 1 over 32. I can factorize out 1 over 32. So I will say 1 over 32 into, when I factorize 1 over 32, it means that here I need 8 to make 32. So it will be, rather to keep it a 4. So I will say 8 pi minus 16 ln 2. Then of course minus pi squared. So that is what we are having, which is equals to 1 over 32 into 8 pi minus pi squared minus 16 ln 2. A question can come when they say, show that the integral of this is equals to this, when it is a proof. So you have to be very technical on continuing up to this point. So that is what we are having. That is what we are having. And I'm going to introduce where we are to integrate polynomial and the exponential functions. That is what I'm going to introduce. Polynomial and exponential functions. It is what I'm going to introduce this in these remaining minutes. so that we see how best we can match there. So polynomial and exponential functions. Polynomial and exponential functions. If we are together on this example, text a yes, text yes, or you can show me that you've understood it. Very clear. So let's go to polynomial and exponential functions. We are going to be introduced to this, and then we see how best we shall move together. Find Roman 1, the integral of xe power x dx. Roman 2, the integral of xe power negative x dx. And Roman 3, the integral of xe power 3x dx. So still for this case, we shall be letting the function which is easily integrated to be dvdx, and the one which is easily differentiated to be u. So solution Roman 1, we shall let our u to be equaling to x, and we shall let our dv dx to be equaling to e to the power x. Now, then it means that our du dx is equals to, our du dx is going to be equal to 1, while our v, when we differentiate, when we integrate e power x, it will keep e to the power x. In other words, it is different from integration. We are going to see that in this section here, it's going to change when we are integrating. Where you have e power 3x, it is going to change. In other words, when it is like e power 3x and you integrate it, you drop this power and it becomes a third e power 3x. So we are going to look at it. But here the power to drop is 1 because you have 1. So even if you say 1 over 1, it will keep that. So it keeps e power x, implying that our integral of x e power x dx is equals to uv, which is x e power x e power x, that is uv, minus integral of v du dx. V is this, and du dx is 1. So it's going to be e power x dx. So this is going to be x e power x minus, when you integrate this, the power is 1 here, the coefficient of x is 1. So even if we say over 1, it will keep like that. So it is going to be e to the power x plus a constant of integration. As simple as that. As simple as that. Even if you use basic technique, you'll have the sign here. You'll have to differentiate some function, and then here you have to integrate. So when the sign is positive, we shall differentiate x and we shall integrate e to the power x. When the sign is negative, when you differentiate x, you get 1. When you integrate x, it keeps the same, e power x. When the sign is positive, you differentiate, you get 0. You integrate, you get e power x. Then you match. This one will match with this, and this one will match with this. Of course, with your table completed and closed. So it would mean that as you match, you're going to have your integral of x e power x, okay, of x e power x dx equaling to, it is going to be x e power x, you match x e power x minus e to the power x plus a constant of the integration c. If it is understood, members, type yes and I see. If it is understood, type yes and I see. If it is understood, type yes and I see you. Interesting. Very good, very good, very good. So now let's do part 2. These ones are very cheap, but the higher we go, as in we shall keep engaging in others which are a bit tight. So we have just started exponentials, and our questions are going to keep getting tighter. So for this one, which is the integral of x e to the power negative x dx, we shall let still our u to be equaling to x, and our dv dx is going to be equaling to e power negative x, implying that our du dx is 1, whereas our v, when we integrate this now, the power is -1, so we shall divide by -1. So it is going to be negative e power negative x. Our v is going to be negative e power negative x. In other words, you divide by the coefficient of what is it on x. So we divide by -1, which is negative. So making all this negative, implying that our integral of x e power negative x dx is going to be equaling to uv x. So it is going to be x times this, so it is going to be negative x e power negative x minus the integral of v du dx. d dx is 1, but v is negative e to the power negative x, then everything dx. So this is going to be equal to negative x e power negative x, of course, plus, when it enters this negative negative, it would be plus integral of e to the power negative x dx. So it's going to be negative x e power negative x, all right? Then when you integrate e power negative x, you divide by -1, so it will be minus e power negative x, then plus a constant of integration. So that is it. Alternatively, you can use basic technique. You can use the basic technique where you have a sign, you have differentiate, you have integrate or integrate. So the sign will begin with the positive. We put a function which is easily differentiated, that is x, and the one which is easily integrated is e power negative x. Negative, you differentiate, you get 1. You integrate, you get negative e to the power negative x. You change the sign to positive, you differentiate, you get 0. When you differentiate this, you will divide by negative, so it will be positive now. E to the power negative x. You split and you relate. So this x will go with this, and this 1 will go with this, implying that your integral of x e power negative x dx is going to be equaling to negative x e power x, because this one is multiplied here. So it is negative x e power negative x. Then here, negative 1 times that will be minus e to the power negative x, plus a constant of integration. If understood, type yes, I do the last example, and we call it a day. If understood, finally, we are going to integrate x e power 3x dx. So with this, we shall let our u to be equaling to x, and our dv dx to be equaling to e to the power 3x. So it would mean that your du dx is 1, and your v now will be a third. Because of this 3, it will be a third e power 3x. Okay, it will be a third u, rather a third e to the power 3x. So now, having that, we can easily move it, and we get the final answer. We can easily move it and get the final answer. So what do? We are going to have it as the integral. This would mean that integral of x e power 3 dx is going to be uv. U is this, v is this. So it is going to be a third x e power 3x minus the integral of v du dx. V is a third, so you can move it out. E power 3x, du dx is 1, so we just have it like that. So this is going to be a third x e power 3x. This will be down, will move down. It will be a third of e power 3x, which will multiply with a third, becomes 1/9. So minus 1/9 e power 3x plus a constant of integration. Even someone who has used best technique, you'll get the same answer. Let me sketch it here. We shall have a sign, we shall have differentiate, and here we shall have integrate. So the sign is positive, we shall differentiate x, and we shall integrate e to the power 3x. When the sign changes to negative, we differentiate, you get 1. You integrate, you get a third e power 3x. You change the sign to positive, differentiate, you get 0. You integrate, it will be 1/9 e to the power 3x. So you match. X will go with this, while 1 will go with this. Implying that your final answer is going to be integral of x e power 3x dx is equals to a third x e power 3x minus, because of this negative, so minus 1/9 of e power 3x, then plus a constant of integration. Our next time we shall look at more examples about exponentials. Then from there we go to inverse trigonometric functions. Then we go to logarithmic functions, and then we progress like that. If any question, please ask, and if not,
Excuse me.
yes, please.
Excuse me, teacher.
Yes, please.
I beg your pardon on how to drop the power, on how to get this a third.
If I have e power bx, if I'm integrating this, you drop the coefficient of x, which becomes 1 over b e power bx. You just drop the power. You drop the coefficient of x. You get the point?
Okay. Yes, I get it.
Any other person to ask? Any other person to ask? All right, let's meet in the mid-morning. Good time.